Alright everyone, welcome back to the stream. Today is day 12 of becoming a full stack developer in 8 months. And first, before starting the stream, I want to take a moment to appreciate you guys and say a huge thank you to everyone that subscribed overnight. As you can see, we have a new daily sub goal that is sitting on top of the screen, and I did this yesterday after not after I stopped streaming, but in the afternoon, and it is less than 12 hours and 18 of you subscribe, which is mind-blowing to me. I woke up to a lot more subscribers and positive comments, which just fills my heart with joy. I truly appreciate you guys, and we'll have to reset it for this sub, so hopefully it works all fine. Reset, go. Right, do I have to save anything? I'm not sure, but hopefully it works all fine this time and the alerts work all fine. Today we have something very exciting. I'll show you guys in a minute. So the sorry. Alright, so the calculator project is fully done. I did some work off stream. Now what is left to do is kind of add comments, so maybe we can start adding comments, and by doing so I'll explain everything that I did. I've added keyboard support, so now I can write with my numpad, for example, and do equations. 7 times 1, enter, 1 divided by 7, and so on. So we're done with the calculator, and actually I have it uploaded to GitHub as well. But as you can see, the calculator was the last project from the foundations course. I wrote fundamentals in the description. I should probably change that, but I'll leave it for now. As you can see, the calculator was the last project, and then we went on to choose your path, and by spinning the wheel I chose Node. No, it wasn't by spinning the wheel, I'm joking, but now we're doing full stack JavaScript. I'm going to sneeze. Alright, so we're doing full stack JavaScript now. We're on to the second part, which is really exciting. The thing is, we'll have to double a bit with intermediate HTML and CSS, but I guess it's alright. But let me go through the calculator project, and I'll explain what I did, and we can add some comments and push it to GitHub. So I've got some basic variables here for the number on the left, number on the right, the operator, if we're expecting num2, if num2 is a percent or not, and if num1 and num2 are decimals. So pretty self-explanatory. This is mapping keyboard keys to button IDs. From then on, we take a collection of all the calculator buttons. We put them in an array where we can get the valid keys from, the basic operators, operator IDs. Probably We could put this in an array as well, but like an array of objects. But anyways, those are the basic functions for subtract, divide, multiply, percent, and so on. Basic calculator functions only allow 14 digits. Okay, just a sec. Alright, so we have the function to actually determine what we're doing. So determine which action we're doing. We can say which calculation. This is for the keyboard events. So listen for keyboard events. Handle key press, I think this is self-explanatory. I don't know why, but in the morning my nose is always runny. It's very annoying. Anyways, this checks if the key exists in the calculator, and then if there is such element, click on it. So what I did last time, and kind of what I fixed, is I started by doing a doCalc function, and depending on whether the button was clicked through the keyboard or through the mouse, it will call the doCalc with the event, and then in that doCalc function I determined whether or not it was clicked by the keyboard or the mouse. It was quite buggy, and I don't think it was the right approach. Then I remembered that you can actually simulate clicking on buttons. So what am I doing here is just checking, listening for the key on the keyboard, then checking if the key like exists in our object here, and if it does, I simulate a click on it, which goes again into this event listener. That was our default one we did, so we're not doing a separate doCalc function, it just simulates a click, and that works a lot more consistent and as expected. So here we're listening for the click events. Listen for click and handle calculations. We could probably abstract it a little bit, but we'll maybe do it later. Alright, so what we're doing here is we're beginning by asking, just mapping the key to the event that we clicked target, that its text content, so whatever is inside the button basically. After that, if where are you learning React from, I am not learning React still, but when I do, it will be from the Odin project. I'm following this FullStack JavaScript course on there, and React is down here after the intermediate, advanced, and JavaScript. We have React, so I'll be learning it from the Odin project. Right, so we're checking in the beginning if the key is numeric, or key is equal to dot or a percent or minus, and expecting num2 is false, and num1 is there is nothing filled in. Basically what that is doing is allowing for num1 to be negative, but also for it to be a decimal number or a percentage, and this is doing the same but for num2. This could probably be done easier or cleaner, but that's how I did it, and maybe we'll refactor it in the future when I got more knowledge. Alright, so this is checking if the input is numeric and allowing num1 to be negative, decimal, or a percent. Alright, and the same but for num2. And I probably don't need is not a number, but we'll see. Anyways, if it isn't numeric, for example, it will return out of it. Now, what is this doing is it's filling number 1 and is filling number 2. So setting num1, this is setting num2, and also it's setting the flags if it's numeric and or decimal. If this decimal or percent, actually not numeric or decimal, and here is the same thing. Right. What we have here is if number 1 and number 2 are not empty and operator is not no, then we go in and do an operation basically. So do an operation only if all the numbers and operator are filled in. And this is if the operator is valid. If it's not, no. I see we have 4 if statements here and nested, and probably we can decouple this, but we'll see. also here what it's doing is checking if percentage, let's do this operation first and then do the global operation. This is for the button equals. I see that this and this is the same, so maybe we can refactor it. Same as T1 above, could maybe refactor it into a function. Alright, we just got a little bit more to do, and what I wasn't talking about is this reset calculator that is just resets everything, and on button clear we do the reset calculator plus we remove number 1 on the display value. Otherwise we don't, we actually set the num1 to whatever although 4 plus 4 plus 8, yeah, so it works fine. All right. I did it like that because if we do 8 plus 8 plus, for example, it has to calculate the expression and put it as num1, and then expecting num2 means we're expecting a second integer. But that is done only when calculating with the operators. If it's done with the equals, we just calculate it and that's it. Alright, and I guess this is for backspace deletes the last thing written. Now what this is doing, it's if num2, sorry, just a sec. This is basically adding the operator from the expression, adding the operator from an expression calculated by an operator. For example, 8 plus 8, 8 plus 8 will give 16 plus, and we wait for second num input. So this is basically the calculator app. I've added comments and hopefully explained a little bit better what I did. The main thing was bug fixing and making the calculator work with the keyboard, which I'm mostly proud of. We're going to do a quick commit. Let me just see the status. Only the script.js is modified. Git commit. Added comments to the code. Okay, and we can push it to GitHub. Perfect, so this is one thing done. I will for now stop the server and close it because we don't need it anymore. and we can dive straight into the intermediate HTML and CSS. Which is also the first lesson from the full stack JavaScript path, and we'll start with the introduction. Alright, so introduction. This is the first of the two-part course where we dig deeper into HTML and CSS. Our foundations lessons by design only scratch the surface of what's possible. We wanted to give you all the bare necessities for getting started so you could move on and be somewhat productive as quickly as possible, but now it's time to slow down and dig in. You have probably realized by now that there are many more HTML elements than we mentioned in our foundations content. Throughout this course, we'll be hitting the rest of the important elements such as forms and tables. There is also a lot more that you can do with CSS that you will learn throughout this course, such as variables, functions, shadows, and of course grid layouts. So buckle up. By the time you finish this course, you'll be able to recreate just about any web design you can find on the internet, which is an important skill to carry forward, even if you are not shooting for a front-end specific job. Being able to make your portfolio pieces look nice is important when it comes to making yourself stand out. You'll learn animations, accessibility, and responsive design in the second part of this course later in the curriculum. And the assignments are: read through this HTML elements reference to get an overview of what other HTML elements are available to you. No need to commit this to memory because you'll be learning the important parts as we go, but having a glance now will help the content stick later. Sorry, my nose is just so annoying, I don't want to blow it on stream. The second thing is take a glance at the somewhat overwhelming looking CSS cheat sheet. Again, we don't need you to learn anything specific or memorize anything from this list, just use it to get a feel for what you still have left to learn, and there are no additional resources, so let's glance over this. We have base, something I've never heard of. Specifies the base URL to use for all relative URLs in a document. This can be only one such element in a document. The head we know, the link we know, meta, style, title, body. Address indicates that the enclosed HTML provides contact information for a person or people or an organization. Alright, I also never heard of this one. Article represents a self-contained composition in a document page, application, or a site. Forum post, newspaper article. A site, I think it's like a sidebar, represents a portion of the document whose content is only indirectly related to the document's main content. Asides are frequently presented as sidebars or call-out boxes. Footer, header, H group represents a heading grouped with any secondary content such as subheadings, an alternative title or a tagline. So this should be present then in almost every website in the hero section, but I've never seen this one. Main represents the document's content of the body, the dominant content of the body of a document, the main content. Nav, navigation, selection page, section of a page. Search represents a part that contains a set of form controls or other content related to performing a search or filtering operation. A quote, block quote, provides a description or definition or value for the preceding term DT in a description list. DL description list. DT specifies a term in a description or description list such as, and as such must be used inside the DL element. Fig caption. HR is represents a thematic break between paragraph level elements, for example, a change of scene in a story or a shift of topics, or like the spaces between paragraphs. List item menu, a semantic alternative to UL, but treated by browsers and exposed through the accessibility tree as no different than UL. It represents an unordered list of items which are represented by list items. Okay, pre represents a pre-formatted text which is to be presented exactly as written in the HTML file. Alright, there are a lot of them. Yeah, I don't think we're going through all of them. Maybe off stream, because I can imagine it's quite boring to just sit and read through all of these. So I'm going to bookmark it, and later off stream I can check it out because it's pretty boring. At least for you guys to watch. Good afternoon, my SQL coding, my friend from yesterday. How are you? I appreciate you tuning in, my man. It's still 6 AM for me. Alright, indeed, they weren't wrong when they said this was overwhelming. This is the box model, the cover picker. So this is like a collection of things done with CSS, or yeah, here you can understand different properties of CSS, I guess, and those are global as well. What's your sleeping time, man? I try to be in bed by 9 PM so I can do these streams before work. I'm just sick. I have work in approximately 3 hours, so I try to wake up early and do these streams and learn before I am overwhelmed by my day job. So yeah, most of those I know, so I think we can proceed with it. We'll mark this as complete, and this is our first lesson from the FullStack JavaScript part already done. Now Emmet I've been secretly using even before that. So what's your current job? A mainframe COBOL developer. So it kind of looks like this. This is what I'm doing. I work in a bank as a mainframe developer with COBOL. Yeah, interesting stuff. Right, Emmet is a plugin built into VS Code that helps you write HTML and CSS more efficiently by providing a bunch of clever shortcuts. By now you have written a good amount of HTML and CSS and you've been using VS Code. There is a big chance that you have already encountered Emmet in some way. I remember back in the day when you had to actually install Emmet and it wasn't like a standard. Just a sec, let me blow my nose. So yeah, fun times. In this section contains general overview of topics that you will learn in this lesson. Some of Emmet's most useful shortcuts: set up custom Emmet key bindings in VS Code. Emmet is a really useful tool for anyone that works a lot with HTML and CSS. Luckily, Emmet does not have that big of a learning curve, and if you already know how to write HTML and CSS, you have no trouble picking up Emmet abbreviations. Let's start off by generating an HTML boilerplate with Emmet, which is the exclamation mark and then tab. Pressing enter should generate the following text. We have just used of many Emmet abbreviations. There are lots of useful Emmet abbreviations that you should check out, like wrap with abbreviations and remove tag. Definitely go through those before moving forward. Okay, so there's some demos we can do. Perfect. Alright. Considering how useful these two are, we'll be setting up VS Code shortcuts for them. Start off by opening the keyboard shortcuts window. Alright, so maybe I should go through these before that. We'll go through them together. Let me just get rid of this. Anything else? No? Okay. Wrap with abbreviation. Sorry, I'm just going to take another napkin because this one is fucked already. My nose is running. I'll be just right back in a minute. Alright, every morning my nose is running. It's so annoying. I don't know what to do about it. But anyways, what is your salary? I cannot disclose, but it's good. But I'm not that passionate about the work. Let's put it that way. A very powerful tool on the Emmet toolkit. It takes an abbreviation, expands it, and places currently selected content in the last element of generated snippet. If there is no selection, action will silently call match tag pair to wrap up text content. Place caret inside tag. So how do you get this window to pop up to enter the abbreviation? Shift Control A. So Shift Control A. Does that really work? Shift Control A. No. Like I can see they do it in the browser, but what did they write again? Wrap with abbreviation. Enter abbreviation. Wrapper H1. Yeah, no way I'm remembering all this. But anyways. Right. He's making them A items. I kind of understand. He will remove the numbering, I guess, this time. Enter abbreviation. AT. Yes, he removed the numbering. This is a lot more than what I use, or I think I need at this point. I don't think I need all of this. Like, let me first understand how to write proper code, and then we can worry about that. Place a caret somewhere. Control K, so on. Alright, now I'll skip over this. I don't want any shortcuts. As of right now, at least. Alright, so SVGs are kind of interesting in that you can do a lot with them, and they always keep its quality, and you can also like do stuff like change their color and so on. So SVGs, SVGs are a very common image format on the web. They can be a little confusing at first, but once you know how to use them, they're incredibly powerful tool for creating high quality dynamic images for your website. In this lesson you will learn exactly what SVGs are, what they're used for, and how you can embed them in your websites. Lesson overview. In this section contains a general overview of topics that you will learn in this lesson. What are SVGs, vector graphics, and XML are, how to create simple SVGs and add them to your website, when to use SVGs, and when a different image format would be more appropriate. So what are SVGs? SVGs are a scalable image format, which means they will easily scale to any size and retain their quality without increasing their file size. They're also very useful if you need to create or modify your images programmatically, because you can change their properties through CSS and JavaScript. SVGs are used for icons, graphs, and charts, large simple images, patterned backgrounds, applying effects to other elements via SVG filters. Okay, but what are they? SVG stands for Scalable Vector Graphics. Vector graphics are images defined by math as opposed to the traditional raster graphics, where your image is defined by a grid of pixels. pixels. With raster graphics, the detail is limited to the size of that pixel grid. If you want to increase the size of the image or otherwise scale it, you have to increase the size of that grid. How do you decide what all those new pixels should look like? There is no simple solution. Additionally, the larger the grid, the bigger your file size grows. And with vector graphics, on the other hand, there is no grid. Instead, you have formulas for different shapes and lines. Since these are just formulas, it doesn't matter how large or small you want them to appear, as they can scale to any size you want, and it will have no effect on the quality or the size of the file. SVGs have another interesting aspect to them. They're defined using XML. XML, aka Extensible Markup Language, is an HTML-like syntax which is used for lots of things, from APIs to RSS to a spreadsheet and word editor software. The fact that SVG source code is XML has a few key benefits. First, it means that it's human readable. That would be better for you guys. If you were to open up a JPEG in a text editor, it will just look like whatever that word is. If you were to open up an SVG, however, it will look something like this. Alright, rect, SVG circle. So it's making a circle 100 width. Nah. I don't think it's a circle then, because it's only 50 height but 100 width, and then it's rounding the corners. At least that's what I think. Just a sec. Alright. It might still be confusing, but hey, those are words, tags, attributes. Compared to binary file formats like JPEG, we're definitely in familiar territory. The second benefit of XML is that it's designed to be interoperable with HTML, which means you can put the above code directly on the HTML file without any changes, and it should display the image. And because these can become elements in the DOM, just like HTML elements, you can target them with CSS and create them using the element web API you've already been using. Element web API, so yeah. Drawbacks. So clearly SVGs are awesome. Time to go convert all of our images to SVG, right? Well, not quite. SVGs are great for relatively simple images, but because every single detail of the image needs to be written out as XML, they are extremely inefficient at storing complex images. If your image is supposed to be photorealistic or it has fine detail or texture, grunge textures are a great example. So if you don't know what a grunge texture is, it's like this. But just a sec. Sorry guys, again my nose is running, I don't want to blow it on stream. But SVGs are the wrong tool for the job. Anatomy of an SVG. Typically you will not want to create SVGs from scratch in your code. Most often you download the file or copy the code either from a website or from an image editor that can create them, like Adobe Illustrator or Figma are two popular apps that create SVGs. However, it's pretty common to download an SVG and want to break or tweak it just a little bit, so knowing what all the bits and pieces are and how they work is very useful. Alright, so we have a class container and SVG underneath. I think this is like the standard, like when you write HTML, it's doc type 5 or something, and this I think is doing the same thing. View box, I think this is the viewport, and it starts drawing inside of it. There is a path, I think it's this line, circle, so on and so forth. In the CSS, circle, hover, SVG text group, opacity becomes 0, so when you hover on the circle, the text that is also SVG just disappears. And they have it explained just underneath what I tried to figure out. So XMLNS stands for XML namespace. This specifies what dialect of XML you're using. In our case, the dialect of the SVG language spec. Without it, some browsers will not render your image or will render it incorrectly. So basically what I said about the doc type, this is kind of the same. And I think again my daily sub go is not working because I can see someone subscribe but it's not showing, and I don't know what to do with it. I'll probably just code one myself because it's very annoying. Before I was using stream elements and now I'm using stream WAPs, still the same thing. Viewbox defines the bounds of your SVG when you have to define the positions of different points of the elements in your SVG. This is what that's referencing. It also defines the aspect ratio and the origin of your SVG, so it's doing quite a lot. Be sure to play around with different values in the example above to get a feel for how it affects the shapes. So we can actually do like 150 here, and so it's not this box itself, is the outside of it, and I think we made it like wider, and this will put it back in the center. No, anyways. The circle, rect, path and text are the basic building blocks. Although you can make extremely complex images with SVGs, they're mostly created with just a dozen or so of the basic elements. Here is a complete list of SVG elements. Alright, perfect. I read through all of this. Many SVG attributes such as fill and stroke can be changed in your CSS. Yeah, I understand most of this already, so Embedding SVGs. There are two main approaches when deciding how to actually place the SVG in your document: linked and inline. Linking SVGs works basically the same way as linking any other image. You can use an HTML image element such as img, or link it in your CSS using background image, URL, and the path to your image. They'll still scale properly, but the contents of the SVG will not be accessible from the web page. The alternative is to inline your SVG by pasting their contents directly in your web page's code rather than linking it as an image. It will still render correctly, but the SVG's properties will be visible to your code, which will allow you to alter the image dynamically via CSS or JavaScript. Inlining SVG allows you to unlock their full potential, but it also comes with some serious drawbacks. It makes your code harder to read, makes your page less cacheable, and if it's a large SVG, it might delay the rest of your HTML from loading. Some of the drawbacks of inlining SVG code can be avoided once you learned a front-end JavaScript library like React or build tool like Webpack. We aren't quite ready to go into those yet, so just keep that in the back of your mind. For now, just do whatever works best for your use case. Linking is generally cleaner and simpler, so prefer that unless you need to tweak SVG code alongside your HTML. So in the knowledge check, the XML and S is like the doc type. It's like the standard we're using. What are some situations where you wouldn't want to use an SVG if it's a complex image with a lot of detail? What are the benefits of inlining your SVGs? What are the drawbacks? The benefits are that inlining your SVGs, you can tweak them via CSS and so on. You can access their properties, and if it's inline, you can also slow down the HTML. Additional resources. This section contains helpful links to related content. It isn't required, so there are lots of free great SVG icon libraries, a font awesome, and so on. I've been working with those. WSG. What's good? I was thinking that's like a SVG library. What's good? Cryptic out of context. Thank you for tuning in to the stream, my man. Really appreciate you. We're doing FullStack JavaScript now, but before that we have a few lessons on HTML and CSS. Alright, and what is this other thing? If you want to get started making your own SVGs, you want some sort of visual editor, it's great for tinkering around with simple SVGs, but not designed for complex graphics. It already looks quite complex to me, just being honest. But yeah, cool. I fucked the sword. Mark is complete, and we go on to the next lesson, which are tables. But before that, I'm going to take a quick break. I've been at it for like an hour, so I'm taking a 10-minute break, and I'll be right back with you guys. Alright, I'm back. Cryptic out of context. I see that you've written something, but I couldn't read it before it was removed, so sorry for that, man. Right. We'll continue with tables, HTML tables. They allow you to create two-dimensional tables made out of rows and columns. In this lesson, you'll learn everything you need to know about HTML tables. This lesson contains a general overview of topics that you'll learn in this lesson. Create advanced HTML tables. Some data just really needs to be displayed in a table. HTML tables might be less commonly used than buttons, links, lists, and everything else you've learned so far, but there are some use cases where they're the perfect tool. Some of the more advanced features can get a little tricky to set up correctly, but getting started with tables is pretty easy. You create a table with table tags and then put the elements for rows, columns, headers, or anything else that's possible inside those table elements. So for example, we have here a table with table row and table heading of first header and second header, and then another row with this data in a cell. Xander, thank you so much, my man. Really appreciate you tuning in. So on. So the columns are a bit, how do you say it? They're not really there. They're made of this and this, but there is not like a column element, or at least I don't know of it. Read through these table basics and tables advanced tutorials from MDN. They should teach you all the syntax behind HTML tables. It's pretty straightforward. Make sure to code along. Right. Right, I already know this stuff, most of it, and if I don't know something, I'll be able to figure it out, but yeah. Tables advanced. Are they making a table inside of a table? Yeah. Alright. Read through CSS tricks, full guide to the table element. This is not working. There you go. Right, anyways, do this table assessment. Open your copy of blank template HTML. Okay, what do you want to do? Add the provided caption to your table. Add a row to the table header. Create. Ensure the contents being placed in the right cell, so on. Right, I'm going to be skipping those. Then Don't get me wrong, I like tables and what you can display with them, but most of this stuff I already know, and I don't feel like I'm going to be using them soon, and when I need to be using them, I'll just learn whatever I don't know, which is not that much. See, this is interesting, but how do they do that? They tell you what they do, but not exactly how they do it, which I would have liked, but nonetheless. Alright. So let's move on. Default styles. Is this like... yeah, those are the default browser styles. Good luck on your journey. Refam, thank you so much, my guy. Truly appreciate you. Thank you for tuning in. I'm definitely going to keep going. Thanks a lot, my guy. CSS reset. I already know that the browser has some default styles like margins and so on, and I've already used CSS reset for this just I clicked on the assignment, but yeah, the CSS reset you would use because you want to make things more uniform. You want to remove everything that you didn't set yourself, that was set by the browsers. For example, there is always a margin set by the browser, and different things. There is a CSS reset file that I was using in my previous project, so it basically removes list styles, does the line height to 1, quotes none, and so on. Just resets all the styles. They are not required, but they are very useful. The fabulous style board contains a few resets you can select and deselect to see how they are affect. That's cool. Let's see that. So as you can see, those are just regular headings, and sometimes you want to change how they are displayed, so you input the reset and it resets all the headings to a default, so you can set them up yourself. But yeah, already know about this. CSS Units. So there are many different units that you can use to define sizes in CSS. This lesson will introduce the most important to you. I'll show you where to learn about the rest of them. This section contains a general overview of topics that you will learn in this lesson. Difference between relative and absolute units. You will learn when it's appropriate to use different units. Absolute units are those that are always the same in any context. Pixel is an absolute unit because the size of a pixel doesn't change relative to anything else on the page. In fact, pixel is the only absolute unit you should be using for web projects. The rest of them make more sense in a print setting because they are related to physical units such as inches and centimeters. Relative units are units that can change based on their context. There are several of them that you are likely to encounter and want to use. EM and REM both refer to a font size, though they are often used to define other sizes. In CSS you see both of them often, so we're going to explain both, but as a rule of thumb prefer REM. One EM is the font size of an element, or the element's parent if you're using it to set font size. So for example, if an element's font size is 16, then setting its width to 4 EM would mean 64 or 16 times 4. 1 rem is the font size of the root element, either root or HTML. The math works the same with rem as it did with EM, but without the added complexity of keeping track of parents' font size. Relying on EM could mean that a particular size could change if the context changes, which is very likely not the behavior you want. Using a relative size like rem to define font sizes across your website is recommended. Many browsers allow users to change the base font size to increase readability. If at all possible, it is advisable to respect a user's wishes. Regarding font size, you'll learn more about this from the reading assignments. The units viewport height and viewport width relate to the size of the viewport. Specifically, 1 VH is equal to 1% of the viewport height and 1 VW is 1% of the viewport width. These can be useful anytime you want something to be sized relative to the viewport. Examples including full height heroes, full screen up like interfaces. So we've got some assignments, but I'm probably going to end this short because my nose is all stuffed. It's very hard to speak and to blow it 5 times a minute, so I'm probably going to end this early today and hopefully tomorrow is better. I'm going to take some medicine. So sorry for the short stream, guys, but I cannot bear with it anymore, so I'm just going to go through it on my own, kind of read it in my head so I don't speak all the time and have to blow my nose. But yeah, thank you all for tuning in, and I'll see you guys either later today or tomorrow. So I love you all, and bye bye.